that means there is either human sewage or human septic influence. That means there are risks with this water body. So instead of doing a full-blown bacteriological or pathological or epidemiological study, these are simple parameters you can use to assess the risk if you have a risk in your system. And 15, I was talking about enriched, so mussel from the lake is N15 signature and caffeine highly correlated. Okay, these are just showing that when you have human influence, you see either caffeine or N15. And then come to some of the drugs. Most of you take ibuprofen. Okay, so that's the constitution of ibuprofen as a function of caffeine. And in Shawnigan Lake, in March, when we have lots of rain, it gets diluted. In August, we have a lot more ibuprofen in the water. So this is in the middle of the lake that we are analyzing ibuprofen, okay, and finding ibuprofen, okay. And that's, by the way, the thing that we are most proud of, our ocean outfall, okay. And another analgesic and antiphyllistic, you have Shawnigan and you have March and August. So in the previous slide, I think it would be important for our Cowichan regional district. You see this star? That's Cowichan River. Okay?
What was that again? Cowichan Bay?
River.
That's Cowichan River. So the number of development, number of lots per square kilometer on a watershed is highly correlated with the amount of caffeine, enterococcus, fecal coliform, enriched nitrogen. All of that comes. And these are the numbers for Shawnigan that I could find. So less than 0.2 hectare lot, there are 179 of them. 0.25 to 0.5, there are 50. So when you have smaller lots around a watershed, and Shawnigan is this, okay? It is highly dense actually, along the buffer zone. The development has been right at the water's edge. So within 200-meter buffer zone, almost all of the residences are on Shawnigan Lake. That's why you have such strong correlation between population density on the lake and caffeine or N15 or enterococcus in the water. I will not, I've already talked about this stuff, so I'll move on to the next slide. So what we have, how many minutes have I used?
30.
30? Okay. What I'm going to take you through now are one of the fortunate things that happened when I started my program at UVic 10 years ago. We had Sook and we had Shawnigan. They're within 5 kilometers of each other. They are almost twin lake. They have a deep north basin, about 60 meter. Sook is deeper now because they raised it by 6 meter last year. So about 60 meter, 180 feet, the deep basin, and about 60 feet or 20 meter shallow basin. And originally they are identical in terms of nutrients, water quality. And these are the changes that happened. In Sook, it has been protected since 1900. There have been dams raised to account for increased demand for water. We have raised the dam 3 times. Every time we raised, we had nutrient input from the inundated land. We had few years of poor water quality and it stabilized. The same thing happened in 2002 in Sook. We had a nutrient pulse because of flooding land and it's getting stabilized and it should be actually much better water quality in the long term. Whereas Shawnigan, extensive development since 1900, more extensively since 1970, and you know why. All Eastern Canadians took over Shawnigan Lake. No, just kidding. And also we had changes in fisheries because of introduced species. one of the species in Shawnigan Lake is smallmouth bass. That smallmouth bass is not a local species. It has been an introduced species. And by the way, if you ever catch a bass that is over a kilogram, do not eat it. It has elevated level of mercury. Okay?
So
Eat the small one.
Would you repeat that? What size?
Over a kilogram, 2.5 pounds. Okay?
Okay.
If you eat it, eat once a month, not more than that. Don't give it to pregnant women and young children. Mercury. So this is some photographs I have. I would be glad to share with Shawnigan Lake people. These are some aerial photographs taken of the entire watershed in 1993. So these are small pieces that we put together, but we couldn't do a good job. But it shows how the lake was in 1993. And this is how it looks like 2005, looking from the space through Google Earth. So this is how the lake looks like. And next one, I'll show you a more focused or close-up look of that area. And you can tell, this is how the lake looks like. Okay? So if you are interested to know about your lake, you can actually do it yourself. This is on Google Earth. You can look and move so it has been extensively developed, and almost all of the developments are actually along the lake margin. Anyway, so that's all I wanted to show you, that you can actually yourself go onto Google Earth and zoom on Shawnigan Lake, and that tells you how the development is going. All right. So in the next few slides, I will show you some of our data, not all of it. I don't have time for all the data that we collected over the last 7-8 years. This is total phosphorus. Come back to phosphorus again and again, because that is the most important nutrient regulating water quality. Okay? And the red line here is the long-term average. There is actually a very nice report by Ministry of Environment, published in 2004. It has some of the long-term data, although it's not continuous, they put it together. And that's where I got the long-term average. So this is the long-term average, and this is where the last 4 or 5 years of data are for phosphorus. So last 4 or 5 years, we are having significantly higher level of phosphorus in the lake, above the long-term average. Chlorophyll, this is, red line is again the long-term average. These were some of the issues and challenges we had in 2007, 2008. I had many conversations with Cauchan Regional Authority, wanted to know what we were finding, what species we were seeing, because they were having complaints from people about taste and odor and all that stuff. So these are some of the peak concentration. Like the left one, chlorophyll. CHL is the chlorophyll, that means total plant biomass in the water. That's an indicator. So these are really high concentration of algal biomass in the